Hello. Today we're going to ask, how do you identify decimals as repeating or terminating? And then, how do you write repeating decimals as fractions? So you can see we're going to clearly focus in on what repeating decimals are. And what a repeating decimal is, it's a decimal where you have at some point a pattern of digits that continually repeat. And that doesn't mean that it's a pattern. It means that you might have 0 and then it just goes 0.3333333 repeating over and over. Or you can have a couple digits that in a row that kind of just repeat, like 1 2 3 1 2 3 1 2 3 1 2 3, so on and so forth. So that's like a repeating decimal. A terminating decimal would be a decimal that ends. And both of those can be represented as like a fraction or kind of a decimal, and we usually put like a line over the top of those decimals there. Now, rational versus an irrational number. A rational number is a number we can write out and kind of understand and communicate as maybe like a fraction. Whereas an irrational number is a number that it doesn't repeat, and a decimal, and it kind of goes on forever in a non-repeating fashion that we can't actually communicate in any way. It just kind of the decimal continually goes on forever. So it's called irrational. Just kind of we'll build on that later. And then finally, this word here, the repeat end, is the actual digit that repeats. So I'll kind of show you an example. The repeat end in this decimal, for example, the repeat end here would be the 3. The 3 repeats, and that's what that dot 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 indicates. And in here, the repeat end would be the 0 9. The 0 9 is the repeat end because the pattern goes 0 9 0 9 0 9. Now let me show you we've talked about identifying decimals as repeating or terminating. So repeating is when you have that pattern going on. Terminating is when they have an end. They don't go on forever. Now, how do I write a repeating decimal as fractions? So say we start out with 0.3 repeating, right? So we just have this 3, it goes on and on forever. We let x equal 0.3. And so if x equals 0.3, we can actually use a power of 10 to multiply based on the number of repeating digits. So in this case, we have 1 repeating digit, so we multiply by 10. We have 1 power of 10, 1 0 on that 10. So 10 times x, and we do 10 times 0.3. When you multiply by a power of 10, we just simply shift the decimal point 1 spot to the right, which if we do that, and we know this is repeating, so it will just become 3 like that. And so we have 3.3 repeating and equals 10x. Now, since x equals 0.3, we can actually 0.3 repeating. We can subtract 0.3 repeating from both sides. So we do 0.03 repeating, but instead of writing minus 0.03 repeating on this side of the equation, we write x, because again, they're the same thing. They have the same value in this situation, which means we end up with 9x, because 10x minus x is 9x, and then 3.3 repeating minus 0.3 repeating would just be 3. We're just kind of basically x getting rid of that, gone. And so now we have 9x equals 3, which we can then divide both sides by 9. So I do 9x divided by 9 will equal x, and 3 divided by 9, or 3/9. 3/9 is equal to 1/3, so we end up with an equation where x equals 1/3, which we can then come back up here and say 0.3 repeating equals 1/3. And now let's try this whole process out with 0.09 repeating. So in this case, we have 2 repeat ends, or 2 digits. So we would say x is going to equal 0.09 repeating. And we would say, okay, since I have 2 repeating digits, I multiply by 10 to the second power, or 10 with 2 zeros, so it would be 100. 100 times x is going to equal 100 times 0.09 repeating. Now again, in this case, I have to basically move the decimal point. There's 2 zeros, so I go 1, 2 to the right. And that means I'd have to extend this out, so I can add a 0.09, because that's basically what it's going to be. It's going to be 0.909 all the way out. So I extend this out. Remember, when you extend these out, you repeat the pattern. You do not add zeros to extend them. You have to repeat the pattern. So this ends up equaling 9.09 0.09 is going to equal 100x. Now, I do the same thing I did in the last one, which in the last example, I got to 10x equals 3.3. I subtracted the repeating part. The repeating part is 0.09. So I do minus 0.09. Oops, I forgot the repeating point. And then over here, instead of doing, I should write that down here. I do instead of doing minus 0.09 repeating, I do 100x minus x. So this ends up equaling 9.09 minus 0.09. So basically I'm canceling this out and I end up with 9 equals, and then 100 minus 1 would be 99x. Okay? Now I can divide out and I can do 99x divided by 99 is going to leave me with x, and that's going to be 9 over 99, which if you reduce this fraction of 9/99ths, you can actually divide this by 9 over 9. So you divide it by 1, which would equal 1 over 11. So x is going to equal 1/11th, which means 0.09 repeating equals 1/11th. And that's why repeating decimals are rational numbers, because I can actually convert them into a fraction and write them like that. Now this one looks like it's hard to see, and I messed. This one is a little bit different. It's 0.48 where the 8 is repeating. So the 8 goes on and on forever. This one's unique because the 4 doesn't repeat. But again, you'll still would say x equals 0.48 where the 8's repeating. Now, since I do have 2 place values, but only one of them is repeating. So since only one is repeating, I multiply by 10, because you decide the power of 10 based on the places that are repeating. So one place is repeating, so that's a 10. 10 to the first, or 10, or a 1 with 1 0. So 10 times x is going to equal 0.48 times, so you can put times 10. I should use dots because I'm using x as my variable, times 10, which would be shifting it over 1 to the right. So this would be 4.8, and you can actually do 88 repeating, 4.88 repeating, and it would continue on like that, because multiply by 10. Now I can subtract. So I would do 10x minus x, and x in this case is equal to 0.48. So watch how I do this, because this is where it gets different here. 4.88 repeating minus 0.48 repeating. Now this is different because x, the 4 isn't repeating. So you actually have to kind of subtract this a little bit differently, where 4, you would actually do 8 minus 4 to get 4, and 8 repeating minus 8 repeating to cancel stuff out to get 0. So this actually becomes 4.88 minus 0.48. You kind of think of it like this. 8 minus 8 is 0. So these repeating 8s kind of cancel out. 8 minus 4 is 4, and then 4 minus 0 is that. You bring the decimal down. So you end up with 4.4 equals 9x. Now we can divide by 9. And in this case, you end up with 4.49ths, which if we wanted to write that as like a regular fraction without any decimals in it, you actually would multiply both of these by 10. So you multiply by 10 over 10, which equals, you move the decimal over, 44 over 90. So the fraction representation here would be that x equals 44 90ths. This can also be reduced, but that would kind of be where you're at there. 44 90ths is what x would equal. And again, so this is one of the more tricky examples. How do you write repeating decimals as fractions? I just showed you 3 examples. And how do you identify decimals as repeating or terminating? We talked about that as well. All right, and that's all.